Hi, and welcome to this little demonstration about the alkali metals. So I'm recording this a couple of days before I'm going to set this for you on Teams. I wanted to really get you up close to the alkali metals so you can see what are their physical properties and how they're different from normal metals, and how do they react with water. So let's get started on the demonstration. Okay, so I've got my alkali metals here. I've got lithium, is the first alkali metal. It has the lowest atomic number. And then if we go down the group, we then have sodium, is the next alkali metal. Its atomic number is higher. And then we have potassium. Okay, now the first thing you can notice is that they're all kept in fairly secure containers. And that is because basically they are quite reactive. So I want to show you them in a little bit more detail. So I've got a camera here which hopefully should be resistant to everything they can throw at us. So we're going to film as well with this to give you a closer view. Alright, so first of all, I'm going to take out the first one, which is lithium. Okay, so here's lithium metal. Now it's stored in paraffin, so that means that it's not in contact with the oxygen in the air. And it's kind of coiled up like that, you can see it in there. And I'm going to take a little bit out and I'm going to cut it. So, out, I take a little piece. Try and fish this bit out there. So that's the piece that I'm going to take of the lithium. Now let's have a look at its properties. Okay, it's grey, it's a metal, so it kind of looks a bit metallic. Now, it's not that shiny, is it, really? So if I cut it, well, actually, I can cut it with a knife. That's weird, isn't it? And you may be able to see that it's a bit shinier there once I've cut it. I'll do that again. You might be able to see it's quite shiny, but then it kind of tarnishes quickly. That's because it's reacting quite quickly in air to kind of rust, basically. So it tarnishes in air very rapidly. That's the first sign that it's quite reactive. Right, now let's have a look at its reactions with water. Now I'm going to be looking at the pH of the water in this tub. Okay, so in this tub I've got loads of water. We put a little bit of universal indicator in, and it should be kind of, put quite a lot in there, should be pretty much neutral, that water. In actual fact, that water, yeah, it's pretty green. So that's, I would say, a neutral pH water. pH 7 is where we'd expect the water to be. And even it might be a teeny bit acid, actually, this water. That's pretty green. It's about pH 7. Right, so now let's see what happens when I put in some of the lithium. Okay, I'm gonna put it in. Here we go. Now, it's covered in oil, so it sometimes takes a little second to get going. But there you can see it is fizzing about quite a lot, and it's producing bubbles of gas. Now, as it's bubbling, you can see the water's turning purple or blue. That is because it's producing an alkaline solution. So that's the first indication that we are doing something to the water. The metal itself is kind of disappearing, but the water is turning quite alkaline there. So we've produced an alkaline solution. So that's why we call them the alkali metals. Okay, and I'll leave that there. The reaction is fairly quick. It's fizzing away. It's not explosive, but the metal kind of disappears within a minute or two, and we get a lot of these bubbles of gas produced. Now, I'm going to test that gas, but I forgot to get my matches, so I'm just going to pause this video and go get a match. I've got my matches, so now we can have a little test of that gas and see what it is. Okay, so back round I go, and I'll turn on the close range camera again. Okay, so in order to test the gas, I've got to have a little piece of lithium. I need a little test tube like this. Now, and by the way, look at this water. This has got really alkaline now. That is a dark, sort of purpley solution. So that pH now is like pH, I don't know, 9 or 10. Okay, I'm going to put the metal in. I'm going to try and catch the gas here. Right, so in goes the metal. And actually what I do is I kind of trap the metal in my tube. There it is. and it should produce a lot of hydrogen gas that I should be able to trap. Okay, so I think I've trapped the hydrogen gas in there. I'm going to be fairly quick about taking it out and putting my finger over it. And then, if I tilt you up this way, I'm going to light a match lit. Let's see if it, listen carefully. Whoa, that was a good one. Was not expecting it to be that good. So that tells me that this gas here, squeaky pop, tells me the gas is hydrogen. So we know that the metal reacts with the water, it produces an alkaline solution, and it definitely produces a lot of hydrogen gas. Okay, brilliant. Now let's move on to the next one. Now the next one in the chain is going to be sodium. So we're moving down the periodic table. I'm going to show you over here actually. I've got a board. So here's the periodic table. The first metal we tested was lithium, atomic number 3, atomic mass of about 7. Now we're going down group 1 to sodium, atomic number of 11, atomic mass of about 23, and then we're going to try potassium, which has an atomic number of 19 and a mass of about 39. Okay, sodium. Again, kept in a similar kind of container. It is, well, this is a fresh one. Okay, brand new sodium. Right, this is packed, oh gosh, it's the first time it's been got out this year apparently. So it's all wrapped up. You know, look at all this stuff that it comes in. Right, so here we go, sodium metal in liquid paraffin. Now, I don't need a lot, because it's quite some serious metal here. So I'm going to take out, that is a lot of it, okay? You do not need that much. I'm going to cut it again. We'll cut the, like, 2 little pieces of it. I'm going to put it back in there, dunk it in. You don't need that much. Now, again, let's look at the properties of the metal. It is quite shiny looking, but it does kind of tarnish a bit in the air. Again, it's cuttable. I can cut it, and that's actually a bit easier to cut. Watch when I cut it, it looks shinier when I cut it, because that surface there is then going to kind of corrode and rust after I've cut it. Okay, now I'm going to put one of these pieces in. I'm hoping that my camera doesn't get destroyed, because this can be a little bit more dangerous. Ready? There we go. Now, it's floating, it's rolling around. Hopefully you can see that. There it goes. Sometimes it will kind of catch fire. Sometimes we'll get a yellow flame produced, and sometimes it does spit. In this case, it doesn't seem to be doing so, but if you look at that blob of metal, you'll see that it's now like a perfect circle. So it's kind of rolling around, it's kind of melting, and it looks like a little ball bearing sort of fizzing around the surface of the water. Sometimes it ignites with a yellow flame, but not always. And it seems to be reacting more vigorously with the water, because it's really kind of moving about as it generates that hydrogen gas. It's acting like a little, almost like a little jet propulsion thing to kind of move it across the water. And maybe you can even tell that that water is getting even darker. It's getting darker, but it's becoming more alkaline. So again, a similar reaction, hydrogen produced, and the water is turning alkaline. You've got to pause the video here, because that water is very alkaline, so it's not really a fair test, is it? I need to replace the water with some sort of fresher pH 7 water, and then we'll see how it goes when I come back to that. Okay, I've changed the water, and we're ready to go with the final one, potassium. Right, okay, take 2 of potassium. Here's potassium again. Right, so first of all, let me show you potassium stored under paraffin. Again, we don't want it to react. So let's take a big piece out. Now that is way too much to use, but I've taken that out because we can see the coloration of the metal. It is dark grey and tarnished on the outside, but if I cut it, watch what happens. It will suddenly become quite shiny. I cut it like that, look at the shininess in the middle there, which I've revealed. Now you can almost see that kind of tarnishing and going less shiny in front of your eyes, because it's really reacting with the air super quickly. Now those pieces are too large, so I'm going to put them back in the beaker. This piece here is about as big as we want to go for the potassium. Now notice that when I cut that potassium, it was actually even softer than the other stuff. So that's another property that changes as we go from lithium to sodium potassium. Things get a little bit softer. Right, okay, I'm going to set you up close here. Notice I've changed the water. This is fresh water, should be pH 7 if I put some more universal indicator in. Whoops, quite a lot. Universal indicator there. Should show me that it's pretty much green. Yep, so the pH is around about 7 in that water. Right, here we go. Is the big one. Let's do some potassium in there. Hopefully my camera is all right. And I'm going to step back because this could be, well, a bit more serious. Right, there it is. Off it's going. You can see it's a lilac flame. It's fizzing quite a bit. There we go. Right, so a little bit of spitting, which is why we have the safety screen here to protect me. The camera seems to be all right. No damage. That's all right. And we can see in there that we've got that alkaline solution produced again. So the classic things there for potassium, lilac flame, and it's more reactive. So that's what we've done. We've done lithium, sodium, potassium in group 1, and now I'm going to show you some videos of rubidium and cesium, and also we're going to look at why that trend is the way it is. All right, so now we're going to do a quick run through of what we saw in the demonstration, some chemical equations that we could write for the reactions that we saw, and then from this you should be able to complete the sheet which I'm setting you. Okay, so hopefully already you filled out your observations on the sheet or in a table of what did you see when lithium, sodium, and potassium are reacting. But now we're going to go over the science a little bit, and then you can complete the rest of the sheet. So first of all, here are the alkali metals. We talked about them well. We did the top 3. There's 3 more: rubidium, cesium, and francium, and those are more reactive, so we couldn't do them in school. They all have something in common in terms of their electron arrangement, and that's because they all have 1 electron in their outer shell. So lithium has 3 electrons. It has an atomic number of 3, and then 3 electrons also. Sodium has 11 electrons. And potassium has 19 electrons, okay? But they all have 1 in the outer shell. So there's their arrangements: 2, 1, 2, 8, 1, and 2, 8, 8, 1. So that means they're in group 1 of the periodic table, and they have similar chemical and physical properties, and they will be able to form an ion. We haven't really covered much of that yet, but they will be able to form an ion by losing that last electron. So properties that we saw that should be in your table, they're all soft. They've all got a low density, which means they're quite light for their volume. And they've got such a low density that the first 3, lithium, sodium, potassium, they are less dense than water, which means they float on water. They also have low melting and boiling points. They are conductors of electricity, although we didn't try that. And they are shiny, although sometimes they tarnish quickly. They go a bit duller because they're reacting with air, oxygen in the air. So this slide again shows us how they tarnish. So here's this top picture here is a picture of some, I think that's potassium, which has sort of fully tarnished. And then down here is some sodium, which has been sort of cut under oil, so it's sort of still shiny. And we can see that how quickly they tarnish changes as we go down the group. So potassium was the fastest to tarnish. Okay, so we could write a word equation for the oxidation reaction. So an alkali metal plus oxygen in the air reacts to become an alkali metal oxide. And there is an example equation of that reaction. You can see that's balanced. We've got 2 oxygens on this side, and we've got 2 here. We've got 4 oxygens there and 4 here. You just have to accept this formula for the meantime. We will learn how to work that out later, but it is Li2O is the formula. And here's another one for sodium, looks very similar. Now you might need these later on to complete your sheet, so you can pause the video or you can come back to it after we've finished. Okay, so why are they called alkali metals? Well, it's because when we take any alkali metal and we put it in water, it makes an alkaline solution. We saw that with the universal indicator. So if we take any metal, let's just give it a symbol M, we'll just pretend like M for metal. So any metal plus the water will become a metal hydroxide, OH, MOH, plus hydrogen. Now this hydroxide there, that OH, is the thing that is an alkali, okay? We will learn more about that later on in a different unit, but OH is hydroxide or alkali. So lithium, it fizzes around on the surface of the water, and here is the word and the symbol equation. We've got lithium plus water goes to lithium hydroxide plus hydrogen gas. Sodium is a similar thing, and in this time it sometimes catches fire. Now we didn't actually see this in our demonstration. Sometimes it does do this. Sometimes it just kind of melts and fizzes around like a blob. It's so hot, the reaction, that it melts the metal, which is why it goes all spherical and kind of like a molten blob of metal. So the word and symbol equations are there. It's again very similar to the previous symbol equation. So remember, if we have any metal plus water, it becomes the metal hydroxide plus the hydrogen gas. Potassium is more vigorous. We do normally see that lilac flame, and again, the symbol equation and the word equation is exactly the same, except we just changed the name of the metal, in this case, to potassium. Now, we didn't do the other reactions because they're more reactive. So why does the atom get more reactive? Well, this is a little bit complex, okay, so stay with me. So this electron here, this outer shell electron, that one, which I'm highlighting in yellow, when a chemical reaction happens, it flies off, okay? It becomes an ion. The atom becomes an ion. That last electron goes off to participate in the reaction. Now, how easy is that for it to do? Well, it depends how close it is to the nucleus. So I'm going to try and add another little annotation. Yeah, okay, so this electron, can you remember the charge? Can you remember it? It's negative, okay? And the nucleus, can you remember the charge? It's positive. So this lithium electron is quite close to the nucleus. Therefore, it's attracted. Therefore, it doesn't want to go flying off and do a reaction. Sodium, the negative electron, is a little bit further from the nucleus. So therefore, it does kind of want to fly off and sort of do a reaction. And potassium is really quite far from the nucleus, okay? So therefore, it's super easy for the potassium electron to fly off and participate in a chemical reaction. So potassium is more reactive. And as we get bigger and bigger atoms, more and more electron shells, that outer shell electron becomes so easy to lose. So after potassium, we have rubidium, and then cesium, and then francium. So here's a little clip of potassium. We saw that, I did that chemical reaction. And there is a clip of cesium, okay? Now there's two things actually going on here. So I skipped one, I skipped rubidium, skipped that one, we just went straight to that one. So cesium is a little bit, is more dense, okay? So density does decrease down the group. So potassium is floating, cesium sinks, okay? You can see it sink to the bottom and then it just, boom, produces loads of hydrogen gas so much, so fast that it just explodes the thing. So we can't do that in school because it's too dangerous. And then here is, I think this is the next one down. No, sorry, this isn't francium. This is actually rubidium. I put them in the wrong order, but this is rubidium. Just have a look at this. And in this one, what they do is they have it in a sealed container in a little glass of water. And that hammer breaks the container, so it opens it, and then the water rushes in, touches the metal, and then kaboom. All right, that's the reaction. So these alkali metals get really reactive as we go down the group. Okay. Oh yeah, there's the three. I'll leave you with that. Potassium, cesium, and then that one's actually rubidium. But francium would be something similar. Okay, so that's the end of this lesson. I'm sending you the sheet to do on Teams. So you should have all that sheet filled out. If you can't print the sheet, that's okay. Just look at the sheet on a computer and answer it all in your book. Okay, then submit the work on Teams so I can see that you did it. All right, I hope that was an okay distance learning lesson, and I'll see you back in school later on in the week. Bye-bye.